I would describe example 2 here as a made-up example to make a math problem that would never happen in real life. I mean, you've got Clara and her 3 friends born on March 11th. You know, how old was each of their friends? What would you do in real life? You would ask them, how old are you? Right? You would never get to the point where you would like, oh, I'm going to set up a quartic equation here so that I can figure this out. The smart person would just say, how old are you? And then figure out the question quite easily. So this is a made-up question so that we can do some math that is very unrealistic, but it's just to get us practicing and seeing how we can use our technology. Because, I mean, this obviously happens. Someone says, how old are you? I'm going to give you a math problem. And by the way, it's 61,136 greater than the sum of their ages. I just figured that out in my head. Yeah, not really going to happen. But it is good practice for how do you set up something algebraically when you don't know a solution, and how do you put information from a word problem into an equation, and then once you have that equation, we'll be able to solve it. And we're going to be solving this with our graphing calculator. So there's some good skills that we can develop here, but the actual question itself, not realistic. Not like the box question that we did yesterday where, yeah, I can see where it would be advantageous to find a maximum volume. So Leslie is 5 years younger than Clara. Mike is 2 years younger than Clara. Thomas is 3 years older than Clara. So everybody's being compared to Clara. So that makes sense that that's what I say is equal to x. Her age is going to be x. Because then I can compare everybody else to her and write expressions in terms of x for them. So Leslie's age, she's 5 years younger, x minus 5. Mike is 2 years younger, x minus 2. And Thomas is 3 years older, x plus 3. So this highlighted in yellow is telling us the information so that we can do a comparison so we can make an equation. The product of their ages was 61,136 greater than the sum of their ages. So I'm going to start, before I put in all the variables, I'm going to just start by using P for product and S for sum, just sort of to set up the relationship. So on one side, I'm going to put P just to start. Now if it says the product was 61,136 greater than the sum, how can I write stuff on either side? I can move the equal side. If you want more stuff on the product side, you can. Where would I put the sum? Where would I put the 61,136 so that I can make an equation that is equal? I'm just going to use S for sum, okay? All right, so let's check this out. So right now we've got the product equal to the sum plus 61,136. The product of their ages was 61,000 greater than the sum. Does that show up here? Is this one that much greater than the sum? And if you put a number in, if the sum was 10, then the product would be 61,146. And then you take those numbers with an example you think in your head and say, does it actually match what we've highlighted in yellow? And it does. Sometimes you might put the 61,000 on the wrong side. So it's good to just do a simple mental math calculation to see, does this work? Does my equation make sense? Because once we go into putting the x's, you're going to get so lost in the algebra for the moment that you might miss that. So in this initial step, I want to make sure that our equation statement is true. Now when we actually write it out, product is multiplication. So there are all of them multiplied together. The sum is all of them added up. I'm going to quickly add them up in head. X plus x plus x plus x is 4x. Minus 5 plus minus 2 plus 3 will be minus 4 plus 61,136. There are a couple of different ways to solve a question like this with your graphing calculator. Without your graphing calculator, it would be really nasty because you would have to multiply this all out, combine all the like terms, and then try to factor it. And it would be an x to the 4. And you can see by the number that the number is very large. So you'd have to use your calculator anyways to be checking it. So since we can use our calculator, we may as well graph it and solve it that way. And I'll show you two ways here that you can use your graphing calculator to solve it. One way is you move everything over to one side, and I'm not going to multiply this out. I'm going to move the 4x over. Can you see I could combine these two as a like term, and when I move them over, I'll get minus 61132 equals 0. And we're going to graph this massive thing. I'm going to just move this up so we can still see it. So I'm going to go y equals x times x minus 5, x minus 2, x plus 3, minus 4x minus 61132. And when you hit graph, if your graph is on a standard window, nothing should show up other than the little thing that it was working for a long time to graph nothing. The reason for that is that graph is outside of this window. You could go to a table of values to see some of the values, and they're here. You can see they're at like minus 61,000, and you could play with your window to try to get it to fit. One of the zoom buttons that's really handy is going down past 7, I think it's number 0. 0 says zoom fit. If you start with that, at least some of your graph will appear. So here's a big x to the 4 graph. What I'm looking for when I make it equal to 0 is I'm looking for an x-intercept or a 0. So in this case, it doesn't show up. It's going to be up over here somewhere. So what I'm going to need to do is I'm going to need to go to my window. My y max, I'm going to need to at least see some in the positive so I can see my x-axis. So I'm going to just change my y max, dealing in thousands here. I don't know, 1,000. So I now have my x-axis. But just like before, that parabola that's down here, I have to go further to the right in order to see more of it. So I'm going to go to my window. My window goes to positive 10. 30 you want to try? Okay. And if the number you choose to begin with isn't enough, you try another one. But 30, sure enough, it crosses. This will also cross over here in the negatives, but x represents Clara's age. And chances are she's not negative 15 or something. So in this case, now I can find my x-intercept by going second, calculate my 0, number 2, go to the left side and the right side. I set my window to go to 30. I'm going to type in the values. Obviously, this one where it's at is to the left. But if I type in 29, that's for sure going to be to the right because I knew what my window was set. It can save you some time instead of hitting the over button and forever. Push enter, and x is equal to 17. So now we know Claire is 17, Leslie's 12, Mike is 15, and Thomas is 20. And if we wanted to check, sure enough, the sum of their ages is 61,136 less than the product. So this is one way that you can use your graphing calculator to solve. It involves making and writing a 0 in. The other way that you can solve an equation like this is you can type in both sides of the equation, 1 into y1, 1 into y2. Sometimes that will be faster. So what I'm going to do for the second one, since I've got two sides of the equation, for a second one, I'm going to write x minus 5, x minus 2, and x plus 3 in one side. And I'm going to write 4x plus 6, 1, 1, 3, 2, because I'll combine those like terms. I'll write that into the second side. And we're going to want to see where these two graphs intersect. I'm just going to delete that out of the first one, and then 4x plus 61, 132. And again, when I graph it, maybe nothing shows up now, because I've got the window was set up for the last one, right? So again, I'm going to go to zoom. I'm going to try the zoom fit, just to see what it comes up with, just as a starting point. There's my one graph, and there's my other graph. I'm going to just, because these things show up, I'm going to just lower. Is that enough to lower? No, maybe not. If you're ever graphing and you realize, oh, I typed in the wrong thing, and your calculator takes a long time to graph something, you're like, oh. You can always hit the on button that breaks up what's graphing and lets you start again. I meant not to change my y minimum. I meant to change, my x minimum. I meant to change my y minimum so I could see more below. Hopefully I can see where it crosses better. Not enough. One more try. There we go. So there's our one graph. Here's our other graph. And it's still not really enough. But we'll just deal with it. So now we want to find, instead of the x-intercept, we're going to want to find where they intersect, number 5. First curve, you just push enter. Second curve, you just push enter. Guess, you just push enter. It's a lot easier to get the solution because you don't have to go left and right. So it's a little bit quicker that way. And you notice that I got the exact same answer for x this way that I did the other way. Okay, the questions you can do that are similarly unrealistic are 7 and 8. There's probably one on the pre-quiz as well. And I'll put one on your quiz tomorrow.